Hello, nieces and nephews. Today we're gonna talk about application layer in chapter 2. In previous chapter, we talk about internet in chapter 1. Okay, let's go. Chapter 2 outline. Part 1 is introduction. Part 2 is client server paradigm. And part 3 standard applications. Part 4 peer-to-peer paradigm. And part 5 socket interface programming. The objective of this chapter is we introduce the nature of services provided by the internet, the client-server paradigm, and the peer-to-peer paradigm. We discuss the concept of the client-server paradigm. We discuss some predefined or standard applications based on the client-server paradigm, such as surfing the web, file transfer, email, and so on. We discuss the concepts and protocols in the peer-to-peer paradigms, such as CORD, Pastime, and Academia, and we show how a new application can be created in the client-server paradigm by writing two programs in the C language. The application layer provides services to the user. Communication is provided using a logical connection, which means that the two application layers assume that there is an imaginary direct connection through which they can send and receive messages. Figure 2.1 shows the idea behind this logical connection. This is a picture of logical connection at the application layer. The Internet was originally designed to provide service to users around the world. Since the application layer is the only layer that provides services to the Internet user, it allows new application protocols to be easily added to the Internet, which had been occurring during the lifetime of the Internet. When the Internet was created, only a few application protocols were available to the users. Today, we cannot give number for these protocols because new ones are being added constantly. Standard and non-standard protocols. It should be clear that to use the Internet we need two application programs to interact with each other. One running on a computer somewhere in the world, the other running on another computer somewhere else in the world. The two programs need to send messages to each other through the Internet infrastructure. However, we have not discussed what the relationship should be between these programs. Should both application programs be able to request services and provide services, or should the application programs just do one or the other? This is example of a client-server paradigm, and this is example of a peer-to-peer paradigm. In this paradigm, communication at the application layer is between two running application programs called process, a client and a server. A client is a running program that initializes the communication by sending a request. A server is another application program that waits for a request from a client. A computer language has a set of instructions for mathematical operations, a set of instructions for string manipulation, a set of instructions for input-output access, and so on. If we need a process to be able to communicate with another process, we need a new set of instructions to tell the lowest 4 layers of the TCP/IP switch to open the connection, send and receive data from the other, and close the connection. A set of instructions of this kind is normally referred to as application programs interface or API. This is position of the socket interface, and this is a socket used like other sources and sinks. And this is use of sockets in process to process communication. This is a socket address. Wow. Example, we can find a two-level address in telephone communication. A telephone number can define an organization, and an attention can define a specific connection in that organization. The telephone number in this case is similar to the IP address, which defines the whole organization. The extension is similar to the port number, which defines the particular connection. Using services of transport layer, a pair of processes provide services to the user of the Internet, human or programs. A pair of processes, however, need to use the services provided by the transport layer for communication because there is no physical communication at the application layer. There are three common transport layer protocols in the TCP/IP switch, like UDP, TCP, and HTTP. Standard client-server applications. During the lifetime of the Internet, several application programs have been developed. We do not have to redefine them, but we need to understand what they do and need to know the options available to us. World Wide Web and HTTP. In this section, we first introduce the World Wide Web. We then discuss the Hypertext Transfer Protocol or HTTP, the most common client-server application program used in relation to the web. World Wide Web and Hypertext Transfer Protocol. And web proxy server HTTP security. In example, assume we need to retrieve a scientific document that contains one reference to another text file and one reference to a live image. Figure 2.8 shows the situation. This is figure 2.8 retrieving 2 files and 1 image. Browser. The URL of this example defines the web page related to one of the computer in the McGraw-Hill Company. The three-letter World Wide Web or W are part of the host name and are added to the commercial host. In this example, in figure 2.10 shows an example of a non-persistent connection. Here we need two connections. For each connection, TCP requires at least 3 handshake messages. This is example 2.4 in the previous page. Figure 2.11 shows the same scenario as in example 2.4, but using a persistent connection, only one connection establishment and connection termination is used, but the request for the image is sent separately. This is a figure of example 2.5. This is formats for the request and response messages. And this is table of methods. And this is table of request header names. And this is response header names. Next example. This example retrieves a document. We use the get method to retrieve an image with the path /usr/bin/image1. The request lines show the method get, the URL, and the HTTP version 1.1. The header has two lines that show that the client can accept images in the GIF or JPEG format. The request does not have a body. The response message contains the status line and 4 lines of header. The header lines define the date, server, content encoding, and length of the document. The body of the document follows the header. This is a figure of example 2.6. Next example. In this example, the client wants to send a web page to be posted on the server. We use the put method. The request line shows the method put URL and HTTP version 1.1. There are 4 lines of headers. The request body contains the web page to be posted. The response message contains the status line and 4 lines of headers. The created document, which is a CTI document, is included as the body. This is the figure of example 2.7. Next example. The following shows how a client imposes the modification data and time condition on a request. Like this, the status line in the response shows the file was not modified after the defined point in time. The body of the response message is also empty. Next example, figure 2.15 shows a scenario in which an electronic store can benefit from the use of cookies. Includes the set cookie header line whose value is 12343. The client displays the image and cookie values in a file named base toys. This is figures of example 2.9. This is the last example, example 2.10. In figure 2.16 shows an example of a use of a proxy server in a local network, such as the network on a campus or in a company. The proxy server is installed in the local network when an HTTP request is created by any of the clients. The request is first directed to the proxy server. If the proxy server already has the corresponding web page, it sends the response to the client. Otherwise, the proxy server acts as a client and sends the request to the web server in the internet. When the response is returned, the proxy server makes a copy and stores it in its cache before sending it to the requesting client. This is figure of 2.16 example of a proxy server. Okay, let's summarize the content of this chapter 2. Applications in the internet are designed using either a client-server paradigm or a peer-to-peer paradigm. In a client-server paradigm, an application program called a server provides services and another application program called a client receives services. A server program is an infinite program. A client program is finite. In a peer-to-peer paradigm, a peer can be both a client and a server. The World Wide Web is a repository of information linked together from points all over the world. Hypertext and hypermedia documents are linked to one another through pointers. The Hypertext Transfer Protocol or HTTP is the main protocol used to access data on the World Wide Web. Okay, it's the end. Thank you everyone. Bye bye.